Hello everyone and welcome to HughesTech's channel. Today we are going to discuss about the role of a very exciting technology, blockchain, in the Internet of Things. The Internet of Things connects people, products and services together in today's world and in parallel offers multiple opportunities for business value creation. Sophisticated microprocessors, sensors, and chips are embedded into physical products, each transmitting data to the network of multiple connected devices known as an IoT network. However, there are a number of technical and security concerns that remain unaddressed for IoT networks. Security in IoT networks have hindered large-scale deployment of IoT devices. These unsecured IoT devices provide an easy target for cyber criminals to exploit the weak security protection and launch DDoS attacks. A breakthrough technology, blockchain, has the potential to help address some of the IoT security and scalability challenges. Let us now understand blockchain briefly. A blockchain system consists of a distributed digital ledger shared between participants in the chain. It provides a way for information to be recorded and shared by a community of users. Within this community, users maintain a copy of the ledger and must validate any new transactions collectively through a consensus process before they are accepted onto the ledger. We will now see how blockchain works. To begin with, a provider and a customer agree for a transaction. The transaction is combined with other transactions to create a data block. This data block is stored in a decentralized global network and is thus verified. The verified block is tagged with other blocks, creating a blockchain. The final transaction is confirmed to both the parties. We will now go through the two key terms associated with blockchain: distributed ledger technology and smart contracts. Let us begin with distributed ledger. The distributed ledger in a blockchain system is tamper-proof, and any update in the blockchain happens only post following the consensus rules. This removes the need for trust among the involved parties. No single transaction has control over the vast amount of data within the blockchain. Smart contracts. A smart contract is a self-enforcing agreement embedded within a computer code managed by a blockchain. This code contains a set of rules under which the parties of that smart contract agree to interact with each other. If and when the predefined rules in the code are met, the agreement is automatically enforced. Smart contracts provide mechanisms for efficiently managing tokenized assets and access rights between the two parties. We'll now look on the spend on blockchain worldwide. When it comes to blockchain tech spend, specifically, IT and business services combined are expected to account for 70% of the global spending. With blockchain platform software identified as the largest area of investment outside of the services industry, this is only forecasted to grow more. The worldwide spend on blockchain solutions is expected to hit almost $16 billion by 2023, according to IDC forecast. Blockchain tech is revolutionary and has the potential to revolutionize nearly every industry globally. But here are some of the most likely: banking, healthcare, education, politics, legal industry, security, government, rentals and ride sharing, charities, and real estate. We will now briefly go through IoT security and its importance. According to Gartner's forecast, the Internet of Things endpoints are expected to grow at a compound annual growth rate of 32% from 2016 to 2021, reaching an installed base of 25.1 billion units. With IoT expected to be such an integral part of today's consumer and business lifestyle, it is imperative that organizations invest in addressing the security and scalability challenges of IoT networks. With the prospect of devices in modern businesses infrastructure growing exponentially, it is a huge challenge to identify, authenticate, and secure the devices. A centralized security model is very difficult and expensive to scale, maintain, and manage. Centralized infrastructures are also difficult to implement in industrial setups where the edge nodes are separated geographically. Thus, a comprehensive IoT security policy is crucial to a successful IoT implementation. So, how can blockchains help improve IoT security? Blockchains work on DLT and hence help build trust in a community. Since all transactions are validated by each user, it reduces the risk of collusion and tampering. No intermediaries are required in a blockchain, and hence it allows removing overhead costs associated with intermediaries. Blockchains help accelerate transactions by reduced settlement time from days to near instantaneous. We shall now look at 4 pain points of an IoT network that blockchains can solve. Let us begin with the first challenge, lack of scalability and validation of transactions. The legacy IoT networks follow a traditional client-server architecture, and they are difficult to scale in a growing IoT network. The solution to this using blockchain is every transaction is validated by other nodes before it gets added to the blockchain. This makes blockchain scalable and fault resilient. The next challenge, insecurity and the associated security costs. Purchasing individual trusted certificates for each device is both expensive and insecure. Other options, such as locally hosted authentication servers, may pose a threat to the IoT network. Authentication of devices may easily become a challenge in IoT networks. Without proper authentication, network is prone to security breaches, which may prove very costly. The solution using blockchains is as follows. Creating a new block involves a large computational time. Thus, as the participating nodes increase in a blockchain, the system automatically becomes very secure without any high costs involved. Blockchain can be effectively used for authenticating the devices and identity of the devices, thus enhancing the overall network security. The next challenge is vulnerable centralized authorities. It is a well-known fact that the centralized IoT authority is susceptible to attacks and the servers can be hacked, resulting in complete device compromise. In a blockchain, each node serves as a centralized authority. Even if some of the nodes are compromised, the network recognizes this and discards the fake block. The risk of tangible damage within IoT networks is the next challenge. With consumer and industrial IoT products increasing, any malicious IoT command and DDoS attacks may cause damage to tangible products. How blockchain can solve this? This is where smart contracts come into place. Using smart contracts, multiple rules and authorization entities are created to refer to a transaction execution, and hence avoid tangible damage. This brings us to the end of this presentation. Are you interested to know more? Visit us at www.hsc.com, or you can also contact us at info@hsc.com. Thanks.